Hey guys, we are back. We're going to learn about 1.3 today. Okay, so this is to give you a framework through chapter 1. What we introduced, kind of what stats was. The first thing I think we talked about was a definition of stats. If you remember that, it's what collecting data, organizing, analyzing, interpreting, and then we kind of looked at different data collection. Things. We first defined, or we went through a bunch of definitions like variable, population versus sample, quantitative, qualitative, so we know how to look at a statistical study. And then from there, we went into 1.2 and we talked about the importance of having accurate, simple random samples, right? Getting an accurate sample as a part of data collection. So what we're going to do in 1.3 is we're going to kind of build on it and we're going to really dig into collecting data. Different types of data collection and all that. And that's actually going to round out chapter 1 for us. So pay attention in this video because it's going to be probably our most dense section of chapter 1. We're going to have a lot of different concepts floating around. I'll try and funnel them in an organized fashion. But you're going to see a lot of different moving parts in here. So if you need to pause it or anything's confusing, let me know. But first, let's review the process of developing a statistical study, and we're going to talk about how this connects to science experiments. Okay, so what do we do in a statistical study? Well, the first thing is we identify our objects. You probably remember this from 1.1. Who is our group of focus, or what are we focusing on? From there, we're picking our variables. You can think of our who as the NFL players, and remember height was the variable we were focusing on. From there, we're going to kind of transition into, okay, I've identified what I want to study. Now, let's figure out some data collection pieces. Am I going to look at a population or a sample? Quantitative or qualitative data, stuff like that. Then we're going to collect the data, which we'll talk about more today. And then finally, as we move on the year, once we learn how to collect and organize our data, we'll get into analyzing and interpreting it. Okay, I hope you do see some connections to the scientific method here. The process hopefully is ringing bells. They are very similar. We're going to focus more on the number side of things, but you should see some parallels here. Okay, so the first thing we're going to talk about today is a census. Now, where does this fit into our grand scheme of stuff? Well, a census is a measurement from the entire population. A measurement from the entire population. Okay, so where does this fit in the grand scheme of things? Well, when I'm setting up my experiment or study or whatever you want to call it, I need to figure out who I'm collecting data from, but also how much, right? Population versus sample. Well, we talked about a bunch of sampling techniques, simple random samples, namely in 1.2. But what if I want to look at the whole population? Because the reality is getting data from an entire population, if done correctly, is going to be more accurate than any sample ever will be because it's giving you the whole picture. Now the question is, well, why wouldn't we use census all the time? Well, think about the US government, right? We take a census every 10 years. That's a lot of work. Think about how much time, money, effort it is to figure out how many people there are everywhere. Ton of work. People don't respond. People are hard to reach. People move, all that different stuff. The big thing you need to know is census, while if done well on a like small scale data, is probably the most accurate. They're a big pain in the butt because they take a lot of time, money, and effort. So that's often why we use samples instead. So that is a census. All right. So now that we've talked about census, again, population versus sample, this is going to be one of the biggest topics we focus on today. Observational studies versus experiments, okay? If we're getting into data collection, these are going to be two different types of frameworks we set up here for how we collect our data. So an observational study is going to be observing and measuring individuals without impacting them or impacting their response. Okay? You want to see a more lengthy definition, please look at your book. That's always a go-to. So observing and measuring individuals without impacting their response. An observational study, the root of that word is what? Observe. When you observe something, you don't impact it. An observational study would be scientists looking over time how the glaciers are melting in the Antarctic or in the Arctic Circle, right? Are they causing the glaciers to melt? I certainly hope not. Or we need to get new scientists. No, of course not, right? They're watching it happen and studying it, looking at the patterns, eating habits, right? A nutritionist, probably the first step in the process of working with someone is just going to observe how they're eating before they ever try and correct anything. Now, not the whole process, but that period of just seeing what they eat, that would be an observational study. Again, a scientist looking at ocean patterns. Great example of an observational study. So the counterpart to that would be an experiment. Okay, so what is an experiment? Well, this is what you've done most of your life. And once you see the definition, it's going to make obvious sense. An experiment is when we deliberately impose a treatment on an individual. And notice here, please, individual and object are interchangeable here, depending on if you're working with human beings or not. So a treatment deliberately imposed on individuals in order to create change. Well, probably not create. That's not the right word. A treatment deliberately imposed on individuals in order to observe a possible change. Okay? It's the opposite of observational. Okay? So an experiment, I'm deliberately imposing in treatment. I'm doing something to see the different results. The example I'll give here is we get a lot of farms around here. Sometimes when you drive on rural roads, and you know this better than me, being from the city, when you drive on a rural road, you'll drive past a field and you'll notice a little section with a sign that says, special chemical being used. What the farmer is doing there is an experiment. Instead of what they've been doing, they are imposing on their crops a new chemical to see if it changes the growth patterns. An experiment, you are doing something. A workout group, think back to the nutritionist example. Well, it's an observational study in that first week when I just see what you're eating. But in weeks 2 and 3, when I give you a workout plan and a different diet to try, I'm imposing a treatment on you to try and impact a change. Okay? So that's the difference between experiment and observational study. Again, observation, you're just merely watching what happens. An experiment, you're doing something in order to try and see what change will occur. Okay? So that's experiment and observational study. Again, here are more formal definitions. If you want to pause it here and look at these, go for it. Scroll down so you can see experiment. Okay. So if you are feeling still unsure about this, try and create your own example. You heard me use the nutritionist and the farmer. Think of an example in your own life and try and think of how an observational study versus an experiment would work. Again, I'll let you do this. If you still are unsure at this point, you could always email me what you come up with, and I can give you the thumbs up or thumbs down based on if it's the correct example or not. But take a second here, try and think of a topic in your head that you're passionate about and come up with your own observational study and experiment. Okay, So now that you've done that, let's talk about the big keys for an experiment. Okay, observational study experiment. We're going to hone in on the experimental world right now. This might not be new for you, but it's good things to go over as we look at different experiments. So the question becomes, what in the world is the control? The control is that field, the rest of the field that didn't get the special chemical for the crops, right? It is kind of, there are a million definitions for control. I'm going to say it's the comparison tool that we do not change to evaluate the effectiveness of the experiment or of the treatment. If you have a different definition of control but the same idea, that's totally fine. We've all heard about control since we learned about experiments in third grade science class, right? We have to have a control in every experiment or we won't know how effective our treatment was. If I just spray the chemical on all the crops, I'm going to have nothing to compare it to. So ideally, our control, it goes through all but, except for the specific treatment I influence, the control exists in the same conditions as the treatment group so that we know how effective our treatment was. Again, control, you probably know this. Not going to spend a ton of time on it. Let me know if you need more explanation. Okay. Another thing we're going to look at, and you might not have never heard this before, maybe if you watch Grey's Anatomy or Scrubs, you will have. We're going to talk about the placebo effect in experiments. A lot of our experiments are actually going to have to do with the medical field, and this is where stats can be very important. And one of the biggest things we see there is the placebo effect. So what is the placebo effect? It is when your treatment group, or your control group rather, not your treatment group, your control group shows improvement without actually being treated. So what I'm going to do here is I'm going to go through these next three definitions fairly quickly, give a brief explanation, and then I'm going to give you a broader example from your book, and I think it'll kind of tie all this together. So is there placebo effect? Improvement without actually being treated. In medical studies, again, as we mentioned with the field, right, we want the conditions to be the same, but changing the one thing. But sometimes what we have to account for is the human brain is a powerful thing when we're working with human beings. So sometimes as we have those controls stay in the same setting as those being treated, they think, or they will show improvement, but they really just feel better because they feel like they're being treated. It's the, it would be like if you have an upset stomach and I give you chalky little circles and you eat them and you feel better. They could actually just be chalk and you're like, wait, why do I feel better? Because you thought they were Tums, right? The placebo effect is when you think you are getting better, but you actually aren't getting better. You just think you are because you think you're being treated. It's why whether it's when you go to the doctor, if the infection is bacterial or viral, if they give you an antibiotic that might not effectively treat it, but because you got medicine, your brain might be tricked into going, well, I think I'm getting better when you're actually not. It's a fascinating phenomenon in the medical field. We'll talk about it more and more as we go on through stats. But if you're passionate about the medical field, placebo effect, there's definitely some crazy studies to look up in the power of the human mind. Okay, double-blind experiment. What is a double-blind experiment? This is when neither the individuals in the study, so those who are receiving the treatment or in the control group, nor the experimenters know who's receiving the treatment? Know who's receiving treatment. Okay, so you might be puzzled here, like, what the heck? Neither the people know who's getting the drug or who's not getting the drug. That seems like a disaster. Actually, it becomes very important in the medical field, right? Think if I'm the president of a pharmaceutical, or I'm a pharmaceutical developer, developed a new drug, and it could be for multiple reasons, but I obviously want my drug to work, right? I want, whether it's for financial reasons, I want to get rich off the drug, or just on goodwill in nature, I see a problem and I think my drug could really help people. When I'm going to run tests on my drug before it goes to market, it's approved by the FDA, naturally I'm inclined, I'm biased to want my drug to work. So one way of controlling that is by having a double-blind experiment. What I would do is I would have an unbiased third party come in and kind of run the experiment, so to speak. So that way, not only do the individuals in the control group and the treatment group not know whether they're being treated or not, that way we could watch for the placebo effect, but also I'm not going to know who is receiving the treatment so that I don't bias my study results. Essentially, it's a buffer to prevent bias. But what you need to remember for double blind, think double blind, no one knows what's going on. It's a third party coming in. Both the experimenters and the individuals being treated or in the control group know who's really getting the drug. Okay? And is it a randomized two treatment experiment? So a randomized two treatment experiment is kind of what we've been describing. It's kind of the big picture of this whole thing. It's when we first randomly assign people to groups. We randomly assign people to groups. That's where the randomized comes from. Randomly assign people to groups. Both think they are getting treated, which can bring in the placebo effect. And then we compare the results. Okay. Again, like I said, this can really bring the placebo effect into play. And it's actually kind of how we control for it. Because you might be sitting there going, hold up, Mr. Carter, why would you treat both groups? Because then the placebo effect will come into play. Yes, but then we can account for it, right? If both groups think they're getting better, then maybe my drug doesn't actually work because of maybe it's really just the placebo effect for both groups. Whereas if we only give one group the drug and the control group just never takes it, we don't know if that group getting the drug is getting better because of the placebo effect or because they're actually getting the drug. So by having both groups think they're being treated, then we can control for that placebo effect. Again, if that doesn't make sense, talk to me. But typically for the medical studies, we'll run the randomized two treatment. Again, both people think they are being treated. So you might be sitting there going, Mr. Carter, this is confusing. You've given a lot of definitions. Put the big picture together. Let me read you a story from the book or an example here, and hopefully it will throw this all together for you. So could chest pain be relieved by drilling holes in the heart? Since 1980, surgeons have been using a laser procedure to drill holes in the heart. Many patients reported a lasting and dramatic decrease in their chest pain. Again, we're drilling little holes in the heart, and they say their chest pain goes away. But they were concerned that the relief was due to the placebo effect. So they ran a research project in New York City to test this. A laser treatment was applied through a less invasive process. So basically, you had 298 volunteers, all who have severe chest pain, that were broken into two equal groups. They were broken into two equal groups. The patients were sedated, but they were awake. So they were not feeling what was going on, but they could hear the process happening. Okay? Each patient thought they were receiving the treatment. They were assigned to two random groups. One group actually had the laser holes drilled in their heart. The other group, again, they were sedated but awake, just thought they were having. They had the laser sounds running the whole bit, people in lab coats, but they weren't actually getting the holes drilled in the heart. So what happened, and the result was the laser patients did very well. They came away going, oh, my chest pains decreased. This is wonderful. But what was crazy was the placebo group showed more improvement in pain relief than even those who got the holes drilled in their heart. As a result, the medical studies, or the medical impacts of the study, were be put under investigation. So how does this example fit into the definitions we've talked about? Well, the first thing you can see is a randomized two treatment experiment happens here. Why is it? It's randomized because the 298 people were divided randomly into two groups. And then both thought they were being treated. So it is a randomized two treatment. Was it double blind? There's no specification in that example that it would be double blind. What would imply a double blind would be as if a third group actually, if the experimenters themselves did not know who was actually getting the laser holes drilled in the chest and who had the fake. But this was not a double blind experiment. There was no indication that they didn't know who was getting, the experimenters themselves did not know who was getting the holes drilled in. Obviously the patients did not. Was there a placebo effect? Yes, 100%. The randomized two treatment revealed that the people who weren't treated reported doing better than those who actually were. Clearly, there's a blaring placebo effect here. So we need to find the further studies needed to be done to try and reduce that placebo effect to actually see how effective the laser surgery was. And what was the control? The control was some people thinking that they were getting treated, but not actually getting treated. So hopefully that makes sense. Again, pages 22 and 23 in your book have that example in detail, and they are phenomenal at explaining these concepts further. If you are confused, you also may email me as well. This is a great chance to pause the video, go get some coffee, get some water, take a little break before we jump into the second part. Okay, if you're back from your break or you're still here, let's just keep plugging along. Okay, let's put this all together here. I'm going to move the camera here to the top left corner so that you can see this. Okay, so what we're going to do here, and this is a practice I want you to do on your own. I don't care how much you do or don't write down, but I want you to pause the video when I finish giving instructions. On the right here, I have 4 different situations, and on the left, I have 4 different types of studies. There's simulations, which we talked about more in 1.1. There's samples, experiment, census. I want you to look at the situations, and I want you to tell me what type of study you would run, statistical study you would run. This is a great way to see if you are kind of comprehending the content, because I know I'm giving you a lot of definitions, but what I care about is can you apply this? So take a second, pause the video, match these up, and then we'll go through them together. Okay, so you have unpaused them hopefully at this point. Let's talk about what should go where. So first example here, study of the effect of stopping the cooling process of a nuclear reactor. Now this took you remembering back to 1.1 some, but I hope you matched it with simulation. With a nuclear reactor or any situation with some significant consequences, please run a simulation, right? If I experiment with a nuclear reactor, you can imagine the consequences of what if something blows up? What if radioactivity leaks out? Could be a disaster. So in any compromising situation, definitely run a mathematical simulation to do the study. All right, study of the credit hour loads of each student enrolled at Van Buren. There's a key word in this sentence here, and it's each. Each student at Van Buren. I didn't say some, I didn't say a summary or a general. Each student at Van Buren. Your brain, when you see each student, you should think every student census. Remember, a census was the first term we learned in 1.3, and it's all about the entire population. So census is what we would do. Study of the amount of time a college student watches TV, and study of the effect of a calcium supplement given to young girls on bone mass. Okay, so think here, we've got a sample and an experiment. Study the amount of time a college student watches TV. There really isn't an indication here that I'm trying to impact the amount of time they watch TV or change the TV watching habits. I just simply want to observe how much TV they're watching. On the flip side, study the effect of a calcium supplement given to young girls. I want to see if that calcium supplement changes their health, specifically how it impacts their bone mass. So I'm giving them a supplement which will impact them. Remember, impact is experiment. So you hopefully made this connection here. Sample, I didn't put observation, but you could do by process of elimination. Not only is this an observational study with a college student watching TV, but we could sample this and still get accurate results. Unlike the each student enrolled at VB, I could just pull a simple random sample of college students and probably get a good idea of about how they watch TV. So I hope that makes sense. Even if you got some wrong, if my explanations make sense and you're like, yeah, I know where I messed up, you're good to go. But if you're pretty confused still, talk to me sometime and we can go through it together. Okay, we're going to kind of switch gears here. So where are we in the big picture? Well, we talked about census, we talked about experiment observational study, then we talked about different types of experimenting, different things we're going to see. But what we see in the broad scheme of things is whether I'm running an observational study or an experiment, or a census sample, anything, when I'm pulling data, if it has to do with people, a lot of times I'm going to survey them. I'm going to ask them questions. That's how I can get data from human beings. But as with anything, we're going to talk about the pitfalls of what do we need to be careful with surveying people. It's kind of like in 1.2 how we talked about the bad ways to pull samples. We're going to talk about the bad ways of surveying people and the problems that could come in to this. So what's the first thing that can come in? What are some problems with surveying people? Well, there's bias. And what is bias? You probably know what it is, but the definition I'll give you is anything that would influence a respondent's answers. Anything that would influence a respondent's answers. And this could be a million different things. It could be my fault as the interviewer. And we'll talk about this a little more, but maybe the way I'm asking the question, maybe it's the tone I'm using. Maybe it's, the environment we're in. Maybe it's some preconceived notions or biases or prejudices that the person answering has. Maybe it's ones that I as the questioner have. Bias can be any and all of those things, and they could all be present. But it's literally anything that could influence a respondent's answers from being absolutely truthful. And it could be subconscious or a conscious decision to be made, and we'll get into that. Liars. I don't really need a definition here. People lie on surveys for various reasons. They could be biased about something. They could be guilty. They could not want to tell the truth. If I know I'm going to get in trouble for something, I might not tell the truth on a survey, right? What's a good example here? If I, as a teacher, send you out a survey and I say, how much on average do you study for my class each week? And we have a test the next day, you might be inclined to kind of doctor or change your answer a bit so it looks good, especially if I'm collecting your information, right? This is why anonymous surveys could be huge, because you're not going to lie on an anonymous survey. But if I'm requiring you to enter your name and we have a test tomorrow and I'm saying, how much are you studying on average? You might be inclined to lie because of the situation. So you got to watch out for liars in surveys. Super opinionated people volunteering to respond. Think of radio shows. The example I'll give you is in Colorado, there was a radio show that asked, should grazing fees for use of public lands be increased? In other words, they wanted to charge the ranchers more money to allow their cattle and their livestock to graze on public lands. And the resounding response was 85% of people who called in said no. But did this mean that 85% of people in Colorado didn't want the grazing fees to be increased? Absolutely not. It's not an accurate representation. Why? Because whether it's responding to a Facebook poll or calling into a radio, the people who volunteer to respond right away or will come talk on the radio about it are often the most opinionated people. Okay, they have the most extreme views. What the radio show found out is, 85% of people who called in said no, but most of those people who called in were the ranchers who would have to pay the increased fee. So essentially, when you run a survey, be careful of having people volunteer to participate because they typically might have an extreme opinion. So you got to watch out for that. I talked about this a bit earlier, but biased questions, right? A question could be super duper biased and influence your answer. The classic example I like to think of is you want to go to the movies on a Friday night with your friends, and you're getting ready to walk out the door, and your mom goes, "You cleaned your room, right?" Okay, but I heard that just saying, "Oh, did you clean your room today?" But saying that you cleaned your room, right? That is a biased question, right? There is no way, if you want to hang out with your friends that night, you are going to say no to that. As opposed to if I, who don't know you at all, you walk into class, I say, "Hey, did you clean your room?" It's not about. I hope you see the difference there. Questions can be biased. You see this a lot with election stuff, or even surveys on. It could be literally anything. I could say, "What is your favorite type of chip?" Unbiased question. I could also say, "Lay's are the superior chip. Obviously, don't you agree?" Different question, okay? And what happens is usually they're not that obvious. Your mom or the example I gave of the chips, they're not that obvious, but they're subtle, and they'll bias you towards certain answers. So watch out for biased questions. In surveys, you got to know, is there an accurate sample being surveyed, right? In studying elections, if you think about the election, we got one coming up in November. Elections, you're going to see a ton of polls coming out. But if we look at the polling data, what's really interesting is sometimes they will poll all the people eligible to vote, but other polls will only look at people who are likely to vote. Is that an accurate sample? If I talk to every single person who's registered to vote, it might be accurate, but there might be some error there because everyone who's registered to vote may not vote. So you'll see some polling groups go a step further and go, well, they'll ask, "Are you likely to vote?" And then they'll only post the results of the people who say they're likely to vote. So you got to be careful are you surveying an accurate sample? There also could be hidden bias. The example I like to give here is of a police officer. If I'm a police officer and I come into this classroom and say, "Have any of you done drugs?" Most of you, again, back to the lying part, are going to go, "No, officer, I have never done drugs." Even if he asks it in an unbiased, he or she asks it in an unbiased manner, like, "I'm not going to tell anyone, but are you doing drugs?" Versus if your friend says, "Hey, have you ever done any drugs?" The hidden bias there is even if they ask the same question, the officer and the friend, and in the same tone, there's bias because the police officer is wearing a uniform. We know that the police and most people, it is generally viewed that doing illegal drugs is wrong. And so therefore, because the law enforcement officer has the power to punish you, the uniform in and of itself is already going to bias your responses. It's not a spoken bias, it is a hidden bias, okay? a hidden bias. So moving on from that, lurking variables. We got to watch out for these in our survey responses. Classic example I love to give is Van Buren football. Okay, let's pretend I'm Mr. Slaughterbeck. I'm the AD at Van Buren, and I really would like to generate some more revenue from my ticket sales at Van Buren football. So I sit there and I go, well, I saw that Taylor Swift is charging a minimum of $75 to go to her concerts. And some people are even paying hundreds of dollars to get the best seats, the 75 or the nosebleeds. Well, she gets a ton. Taylor Swift over here has huge attendance, and her ticket sales are super high. Van Buren football, low attendance compared to Taylor Swift, and we don't charge a bunch. Well, what should I do? I should charge more money. Then more people come to the Van Buren football games. At this point, you might be sitting there going, Mr. Carter is an idiot. Of course not. And right, we all know, right? Charging more money is actually going to get less people at the Van Buren football games. But I've made a good analogy, so what's the problem here? The problem is the lurking variable. You see, a lurking variable is an underlying cause in an experiment. An underlying cause in an experiment. An underlying cause in an experiment. In this case, what's the difference between Taylor Swift and Van Buren football? Well, sorry, football team, but Taylor Swift is a superstar. She's more popular, right? And even though Van Buren football might be popular in Van Buren, Ohio, in the grand scheme of the world, Van Buren football is less popular. In this case, popularity is the lurking variable. The reason that Taylor Swift's attendance and ticket prices are high is because she's popular. The reason relatively, again, I'm not knocking the Van Buren football team here, but the reason their attendance and money is low is because they are less popular. Popularity is the underlying cause in the experiment. Another example, carrying a lighter in my pocket means I have an increased chance of lung cancer. Is that true? Well, the correlation is there. If I carry a lighter in my pocket, I am more likely to have lung cancer. But does the lighter cause the lung cancer? Of course not. What those two things have in common is the underlying cause or the lurking variable of smoking. People who carry lighters in their pocket often smoke. Smoking is one of the leading causes of lung cancer. Smoking is the lurking variable, okay? So an underlying cause in an experiment would be a lurking variable. Finally, we have overgeneralization, right? Just because if you run an experiment, we do everything right and it goes well, okay? Our hypothesis turns out to be what we thought it was. Let's say I'm developing a drug, right? And I see that I developed this drug in a lab and I test it on rats and it improves rat speed when they run through a little plastic tube by 33%, a huge margin, right? The rats are fast. And we go, oh my gosh, it's a breakthrough. Everything went right. The science was correct. I ran a good study. I can still err by then turning around and going, I'm going to use this drug on wild horses in Montana, and then I'm going to tame them, and we're going to win the Kentucky Derby for the rest of our lives. That is overgeneralization. It's taking the results of an experiment and applying it to situations that do not connect to it reasonably, right? I could take my study results and go, this could apply to other rats. And that might be a stretch in some cases, because of different constraints of the experiment, but it wouldn't be too far. But going straight from this drug help rats be fast to I'm going to win the Kentucky Derby with horses from Montana because I'm going to give them this drug, way overgeneralizing. That's an error. Okay. We went through a lot of content there and a lot of different pieces. Now, what I would encourage you with is I think a lot of this you already know, and a lot of it's common sense, right? Once you know about lurking variables or overgeneralizing, you go, oh yeah, that makes sense. Bad things in surveying. So what I want you to do from here is, I think you're going to get this. I want you to try the homework problems, the 1.3 practice posted on Schoology, and see how you do with these. And then any areas you screw up on, go ahead and contact me so that I can help you. I know we went through a lot, but to give you kind of the summary of the broad picture, as we get into the meat of collecting data, it actually can be more complicated than we think, because there are a bunch of different ways we can do it. We learned that we could not only pull samples to do studies, but we could also look at the whole population. And the term that we use for that is a census. We then talked about, okay, I'm collecting data, but do I want to just observe stuff, or do I want to impact change? And aka observational study versus experiment. And if I want to run an experiment, what are the different types of things I could look for? And we talked about the placebo effect, double blinds, randomized to treatment, and all that. And then within that broader picture of whether we're doing an experiment or observation, or we're doing a sample or a population, if we're working with human beings, we often survey them. We often ask them questions. And then we talked about all those pitfalls. So again, a lot of information. Take your time. Again, check out page 25. That'll be super helpful. Really, the section in the book isn't too bad. If you want to read that over, that'll be good. As always, email me with questions, and have a great rest of your day.